Welcome. We've got just a couple problems, and it's mostly just calculator issues here. Actually, the last problem that we did in this section was asked us to do a calculator. Was in this section using graphing calculator, but we did not. I did not do that in the homework set just because I thought it was worth seeing it by hand. If you did this one by calculator in your homework, that's absolutely fine. So to do this, we're in parametric equations. The parameter is theta. Theta determines x, theta determines y. So on our calculators, we need to go into mode. And in mode, our TIs are typically set up to be in function mode. And that's why we get f of x equals or y equals. We want to go down to there and go parametric. And now when I go into y equals, I already had those entered, so I'm going to clear those out. You'll see we have an x1, y1. That's like the first graph. So that would be like our x equals 4 secant. So that is 4, as we know, divided by cosine. And when I hit the x button here, it actually puts in a t, because typically in parametrics we're dealing with time. And then 2 tangent of t. Now I'm going to go to window on this and give some thought here, and mine's kind of set up nicely for it. You'll see that we've got x equals 4 secant of theta, y equals 2 tangent of theta, and this 6.28 ought to make a lot of sense. That's 2 pi, because we know that if I put in 2 pi in for theta, it's the same as putting in 0. So we've made it all the way around the circle, and we're starting with values over again. So 0 to 2 pi makes a whole lot of sense. Our steps, this is how big we step by. I'm just going to make it an even 0.1, no big deal. And x min, x max, y min, y max, we may come back and play around with that, but let's take a look here. And that looks kind of familiar. What seems strange, I'm going to slow this down so we can really track it a little bit better. If I go back into window and I go 0.02, it's going to graph a lot more points. So let's see how that plots out. See, it's building this arc of a hyperbola, and then it jumps down, builds this arc of a hyperbola, jumps down, builds that. When it's jumping, we think the calculator is really smart. It's drawing in the asymptotes. It's not smart at all. It's just taking a point that was over here, and the next point is over here, and it's saying, I guess I should connect those. But you can think of these as the asymptotes. It is just a hyperbola, and let's see what we've got here. It appears that, just going to try to graph it somewhat to scale. I don't know why I could have done a lot better than that. Let's put it over here. Got a little sideways there. Center almost clearly is 0, 0. 1, 2, 3, 4. It looks like we've got a vertex and a vertex. And if I could sort of track here, turn off my calculator here, it looks like maybe by time we go over 2, we're up in the neighborhood of 1. I'm just trying to get a reasonable curve here, but it looks like maybe that asymptote has slope 1/2, up 1 over 2. And that's all we're doing. You know, it's just a graph. 1 over 2, 1 over 2. We could go through a proof, and we could probably show that it's a hyperbola, but I believe it's that way. But just a point, if part of a graph looks like a hyperbola and looks like they're drawing the asymptotes, chances are it's a hyperbola, and the asymptotes shouldn't have even been drawn. All right. So second graph, y equals clear and clear. T divided by 2 for x, and then ln, boy, I wouldn't want to do this problem without my calculator, t squared plus 1. And I'm going to go zoom standard on this one. That's just our -10 to -10. We're not 2 pi. The 2 pi really makes no sense to use as a boundary in this problem. This is not angle measures or anything, so I'm just going to go zoom 6, zoom standard, and see what we've got here. And we just have this itty bitty little bit of a curve here. So let's go back to our window. Oh, I still had, oh, because zoom max or zoom standard only affects the X max X min. So this would probably be a pretty good case. Let's go -10 to 10 T min T max, because T can really be anything, because this T squared plus 1 is always going to be positive. Therefore, I'm not going to have a logarithm of a 0 or a negative, and I can divide any number I want by 2. So let's see what that does for us. I'll just go 0.1 here, clean that up. Okay, and now's when we got to get smarter than our calculator. It looks like we got this little bird curve. There's a good chance that continues forever, because I can put really big values of T in. So let's go window, let's go -100 to 100. I'll go by 0.2 just to speed things up a little bit. Oh, and my calculator is about to die here. And sure enough, we've got this bird. And all we're going to draw is just a reasonable facsimile of this. Looks like it's kind of curved down here for a moment. I don't believe it ever levels off. I believe it's going to continue up forever, because the Y values are going to keep getting bigger and bigger. The X values are going to keep getting bigger and bigger. So that's all we're looking for in this. We could investigate that further, but that should take care of it for you. The big key there is mode parametric. Let me know if I can help.